Hello students, in this video we'll discuss basic properties of conditional expectations and how they relate to martingales. So the conditional expectation, so given a random variable x and a set A, we have the following formula. The conditional expectation of x given this set A is the expected value of x on the set A over the probability that A occurs. I can take this definition of conditional expectation of a random variable with respect to a set and generalize it. So if we have, suppose that y is the simple random variable yj on the set aj. So that tells me that y will output yj on the set aj. So we can define y piecewise as saying that y is equal to y1, it's the value y1 on the set a1, down to yn on the set an. I can use this definition of conditional expectation to condition the random variable x on the random variable y. We'll say by definition that the conditional expectation of x given the random variable y will be the following piecewise function. It will be the conditional expectation of x given the set a1, this conditional expectation, on a1. So on a1, that's the same thing as saying that y is equal to y1. And the conditional expectation of x on an, that's the set when y is equal to yn on an. So this conditional expectation is giving me the best guess information about the function x, if the random variable x, if I know the information on these individual subsets. Now there are several properties of conditional expectation that we'll make use of. So here are the properties, and we'll see how they relate to martingales. So the properties of conditional expectation are the following. The first property is that if we're given a collection of subsets f, as we were here, in terms of y. So in terms of the collection of subsets in this example, the collection of subsets will be a1 through an. But if I'm given any collection of subsets f, the conditional expectation is the following properties. The conditional expectation of x given f is equal to x if x, the information of x, is contained in x, in f. Of f. The conditional expectation of x given f will be equal to the expectation of x if x is independent of f. So if the information in x is contained in the information of f, then the conditional expectation will output the random variable x. If the information in x is independent of the information from f, then the conditional expectation outputs the ordinary expectation. Then we have the tower property, that the conditional expectation of f, if I do the conditional expectation with respect to g, I will get the conditional expectation of the smaller amount of information will be equal to the conditional expectation of x given g if g is a smaller amount of information than f. So we will use these properties in conjunction oftentimes to find out when something's a martingale. So we will say that we'll have a martingale sequence. So if I have a sequence of information that is increasing, and a sequence of random variables is a martingale if the conditional expectation of the n plus first given the nth information is the nth bit of random variable. So what we can see is we'll now see an example of how I can use the definition of a martingale and the properties of conditional expectation to construct a martingale. So what we'll do is we'll look at the following example. Given an increasing sequence of information, or we can think of them as finer and finer partitions of the probability space, and x, I will construct Mn as the conditional expectation of x given the nth bit of information, and I claim that this conditional expectation, this random variable, is a martingale sequence. And so what we need to verify is we will need to verify that the conditional expectation of Mn plus 1 given Fn is equal to Mn. So I will now fill in what this is equal to. So I know that Mn plus 1, by my definition, will be this term over here with Fn plus 1. So this will be the conditional expectation of x given n plus 1. And then I will condition this on Fn. Now I will use my Tower property of conditional expectation. So this is oftentimes referred to as the Tower property. The Tower property will tell me that I choose the smaller of the sigma algebras of the information set. So this will be equal to, by my Tower property, the conditional expectation of x given Fn. And we see by definition that that is Mn. So I've shown the conditional expectation of Mn plus 1 given Fn is Mn, and this tells me that the sequence is in fact, that Mn is in fact a martingale. So these are the three fundamental properties of conditional expectation. If I condition a random variable on information that the random variable knows, I output the random variable. If I condition a random variable on information that's independent of the information from the random variable, I output the expected value of the random variable. And finally, conditional expectation will always choose the smaller amount of information. So if I condition on large information and small information, it's the same as conditioning on small information. These three properties are oftentimes used to establish a sequence as a martingale sequence, which will be very useful for us when we're making financial decisions. Thank you very much.